We can define a parabola with the equation y squared equals 4ax. The parameter a is a value that controls the size of the parabola. But we can also define a parabola as a locus of points, controlled by a point called the focus and a line called the directrix. We will see how to do that in this video. A locus is a set of points that obey a particular rule. A parabola can be constructed as a locus. We first need to define a point called the focus. For a standard parabola y squared equals 4ax, the focus needs to be at the point a0. We then need to define a line called the directrix. For this parabola, the line must be parallel to the y-axis at a distance a to the left of the axis. In other words, it is the line with the equation x equals minus a. The parabola consists of all points P where the perpendicular distance from P to the directrix is equal to the distance from P to the focus. How do we find these points? Well, we can pick any point D that is on the directrix and draw a horizontal line, which of course is perpendicular to the directrix. We now need to find the point on this line that is the same distance from the directrix as it is from the focus. If we try this line, clearly the line DP is shorter than FP. If we try this line, the line DP is longer than FP. Somewhere in between, the two lines are exactly equal, so this point P is on the parabola. We can move our horizontal line to a different position and again find the point P where the two lengths are equal. This point is also on the parabola. If we repeat this for various points, including points where y is less than 0, we can see the parabola shape. The full parabola consists of all the points that obey the rule. Now let's prove that the locus is the parabola at y squared equals 4ax. We start by taking any point P with coordinates xy that is on the curve. We then find the lengths PD and FP in terms of x and y. The line PD is horizontal. D has an x value of minus a, and P has an x value of x, so its length is a plus x. We will need to know PD squared later. This is a plus x squared, or a squared plus 2ax plus x squared. To find the length FP, we first form a right-angled triangle, FPQ. Using Pythagoras, we know that FP squared is FQ squared plus PQ squared. F is at a0 and Q is at x0, so the length FQ is a minus x, and FQ squared is a minus x squared. Since P is at xy and Q is on the x-axis, the length PQ is y. PQ squared is y squared. So we have this equation for FP squared. We can expand this. Since FP and PD are the same length, it follows that FP squared equals PD squared. Substituting the expressions we just calculated for FP squared and PD squared, we get this. The terms in a squared and x squared cancel out, so the function can be simplified to y squared equals 4ax, which of course is the parabola formula. A parabola is really just a quadratic curve. When we look at quadratic curves, they usually take the form y equals f of x rather than x equals f of y. We can use a locus to draw a parabola of this form. We put the focus at point 0a. We make the directrix horizontal with the formula y equals minus a. Since we've swapped the roles of x and y in the locus controls, we must swap x and y in the formula of the curve. The formula of the curve is now x squared equals 4ay, or alternatively y equals x squared over 4a. If you enjoyed this video, please subscribe or visit graphicmaths.com. The link is in the description below.